All right. Hello, everyone, and welcome to 4C. I hope you're enjoying yourself so far. My name's Ben Wilson. I'm a senior environment artist at Machinegames. Today, we're going to take a look at some of the texturing techniques used for the environments in Wolfenstein 2. But before we do, let me give you a little bit of background about me. I've been in the industry for about 8 years, but I actually go back well into the dark modding days. I had always been interested in art from a very young age, and by my early teens, I had started to become interested in video game development. It quickly became a hobby for me, and being young, I valiantly declared that this is what I want to do the rest of my life. But then my high school, they refused me art on the basis that I wouldn't pass and wouldn't be able to keep up with the coursework. And honestly, it kind of killed it for me. So after finishing school, I went into programming at college because I still love games and I couldn't do art. So I ended up, I actually ended up dropping out of that. So I then moved on to what I thought was the next closest thing to games and took an animation and visual effects degree. Well, that course then shut down halfway through. So I was lucky enough to actually find another university to let me sort of pick up my half degree and finish it. The thing was, I was still modding throughout all of this, and I had found myself working with a wonderful team on Chivalry Medieval Warfare. And this game, it really became my first step into game development. And since then, I've worked on a number of projects. And 2 years ago, I joined Machinegames, where I'm now mostly focusing on environment texturing and pipeline setup. But that itch, it never really goes away for me. I still enjoy creating content outside of work. And in fact, my most recent personal work is a fan art for a local Czech studio, Amanita Design. And in a way, substance designer it's like artistic programming, and it's something that really appeals to me. So an awful lot of my personal work recently is revolved around this tool. And when I was actually putting this presentation together, I started to realize I might have a thing for debris. In every studio I worked out, I'm building debris in some way or another, or working with grounds. And I'm even doing it at home. But what might be worse is I've spent the last 5 years of my life building different versions of Manhattan, and I've never even been to New York. But OK, enough about me. If you haven't played Wolfenstein, it's a first-person shooter set in an alternate universe where Nazis won World War II. And for those who have, here's a little refresher.
Welcome back to America's #1 game show.
My brothers and sisters of the United States of America, tonight, we, the free people of the resistance, ask you to become one of us. Did you forget? They beat us. They murdered us. They executed us. They fucked with the wrong country.
Come and fucking get me, you fascist Nazi pig!
You keep playing where you shouldn't be playing.
And if tonight we see you on the streets with a knife, or just your clenched fist fighting the powers that be, then you are one of us!
These boots are made for walking.
Tonight,
And that's just what they'll do.
they burn.
One of these days, these boots are gonna walk all over.
All right, so as the title suggests, we're going to take a look at the Manhattan map. If you saw our talk from GDC earlier this year, you'll be familiar with that map. That talk, however, was more about rubble creation. Go figure. Today is going to be more about the actual production and philosophy side of texturing. Now, as I'm sure most of you know, making a full environment is really tough. It takes a lot of work, especially when you have tight deadlines and production constraints to consider. It can be pretty overwhelming trying to work out exactly what you need to make and how you're going to get it into performance. So where do you even start? So this talk will hopefully address that and give you an idea of what the production looked like. Now, we only have a few minutes. It would be impossible to cover the whole map. So instead, we're going to start by looking at some concept art pieces, and then how we went forward to breaking that down. We'll then move on to how we actually created a plan from this, before moving on to how we actually executed on that plan, and, and how that sort of translates into an actual pipeline and some of the actual assets for the game. And then finally, we'll discuss a little bit about the Substance tools and how the work that was done for the map can then be translated into greater value for the studio as a whole. Now, Substance was our main texturing tool, so most of the talk is centered around Designer and Painter, but hopefully everything we talk about is broad enough to be applied to any texturing package. Now, I primarily worked on the map alongside another artist, Ivan Martinez. But of course, there's a whole host of characters that contributed to the map. It's impossible to list everyone, but these are the worst offenders. As a side note, these images are also hidden around the map, so if you haven't played the game yet, now's your excuse. Now, Ivan and we actually came onto this map after an initial blockout was already in place. This meant that most of the modules and metrics were already defined. One of the other senior environment artists, Ray Wegner, he did most of the work here, and you can see that he left us with a really solid base. So all we needed to do really was just devise a plan to texture and ship the map. Okay, so we'll start by taking a look at some concept art. There were a lot of concepts made for the map, but the one in the middle is what we're going to focus on today. It's the concept for the area you just saw in Blockout, and it depicts a heavily destroyed hotel. So we started with identifying what textures we need. We're looking for the core materials that make up the image. It's stuff like the wallpaper. Obviously, wood is a big feature of this, and there's kind of three main types here. We have like the frames and trims. There's more of a decorative wood and the floor planks. And then we have these sort of structural elements like the brick and these girders. Like these floor tiles are really nice, big feature. And then, of course, there's plaster everywhere. Now, at this point, you might notice that all these materials we're calling out, they could be considered as sort of base materials. They're materials in their purest form. While on top of this, you have this kind of environment layer. It's sort of burned in places. There's a lot of ash and dust. Like these materials, they're conceptually different. There's something that's related to the state of the world. And ash isn't inherent in floor tiles, for example. It's something you layer on top. Now, as I mentioned before, the blockout was already in place, and most of the modules were at 3 meters. We did have a general target textile density ratio of 1024 pixels a meter, but since our modules were 3 meters, we decided to offer the map at 768 instead. And this would let us put a 2K texture cleanly onto a 3-meter model. Now, while this ratio is lower than some of the other maps, what's important is that everything is consistent. Like your brain is much more willing to accept an image if everything is evenly detailed versus, say, like a super high-res chair against a low-res background. So having thought about the concept art and collected any reference that we needed, we started to piece together a plan. Now, we wrote everything down, specifying what assets we're going to need. I know this is pretty awful to look at, but we actually did everything on paper, so this is the friendly version. And it's also only the hotel area. But I do think there is value in seeing what we actually wrote. This talk should be online later, so you can check it out in more detail. But I do want to emphasize how important this step was for us. It helps us see, the full picture of the environment. Like, gives us a rough idea of how many textures we're going to have, how many variants we're going to need, what's tileable, what's unique. It makes it easier to see what you can reuse elsewhere and give you a rough idea of memory usage. And in that list is that environment layer that we called out before. And I'm drawing attention to this because we're not just listing what materials we need here, but we're also thinking about how they're actually going to be used. Like, these two materials are how we're going to ground everything together and make it all feel like it belongs in the same environment. And we'll be coming back to these two in a moment. So in addition to this list, we also blocked out what some of the textures would actually look like first. And what we're doing here is we're looking to identify what meshes we're going to need to build and roughly how they're going to fill into UV space. So here you can see that we've allocated space for a large beam, which is highlighted in red, and then two planks, floor planks that are shown in green. And then there's a whole bunch of damage variations for each. And you'll also notice that we actually left some free space for things that we might not have thought of, which ended up being very useful. So when it comes to actually building the high polys, much of the guesswork's already done. We already have a rough idea in mind of what the meshes should look like. So this is what we actually ended up with. You can clearly see the influence from the mock-up texture. Some things did change, though. We never built those fin strips, for example. They were going to be unique side details and caps to close the meshes. And we ended up adding some more variations, as well as this metal cap, which proved to be really useful just plugging small holes and gaps around the map. And this is the result of that applied to some meshes. Here's another example of wall trims. And what I want to point out here is that we're taking measurements and metrics for all of this. And taking these measurements is important. So if we have any variants, like this damage version, then we know that they're going to snap together cleanly. And as with the floorboards, it informs, much of the guesswork is already done and informs how the high poly should look. And like before, some things did change, but generally our mock-up texture was a pretty good representation of what we actually ended up with. So here's those textures applied to some assets. And because we spent the time to plan and measure things, we know that both the modules and the textures are all going to snap nicely together. Now, I'll spare you the rest of the process, but this was done for any texture that we felt needed it, as well as the whole map and any meshes. But by the end of it, we knew almost everything that we needed to make. So at this point, like, we know what we need to build, but not necessarily how. Like, all these textures, they need to work together, and not just from a visual standpoint, but also a technical one. So in much the same way you would define gameplay metrics for, say, like windows and doors, you should really define some metrics for textures. Now, this might sound weird to have a metric for a texture, but hopefully I can show you what it means and why we think it's important. So let's discuss these two height maps. Say you have this broken concrete and this dust material, and their height maps look like this. Now, notice that both the height maps are using the full range of black and whites. Like, this is usually good. You're maximizing the range available in the texture after all. The problem is that this concrete height data represents something like 20 centimeters worth of depth, while the dust is only, like 1 centimeter or something. So what this means is that anytime you use these maps together or have settings which depend on them both, you're going to have to be manually adjusting each material separately because the data that they're representing is inconsistent with each other. What that essentially means is that they're difficult to blend together or really just reuse them in any way, especially if you're intending to use them inside of Substance Painter, for example. So instead, we could define some basic metrics to work within, like establishing a total height range that any given height map could represent. And then each height map could then be authored around the mid-gray value, with mid-gray representing no displacement. Anything above that is positive displacement, and anything below is negative. Now, incidentally, this is how Substance Painter expects your height maps to be. So if you intend to use your materials in there, then you should really be set up like this. Now, inside Designer, the high-res plane is actually assumed to be 1 meter when your tessellation height scale is set to 100. You can see that it will actually produce a 1x1 cube if I plug in a pure white square into the height. So using this, we can actually work out what our values should be if we want to be working in centimeters. So your height scale is essentially your target depth divided by your surface size. So if I simplify that, and what we're really saying here, and if we use the cube as a previous example, is I want my height map to represent 100 centimeters worth of depth, and the texture itself covers 1 meter of space. Therefore, my height scale is 100. Now, conveniently, Designer has a height to normal node, which lets you input both the target depth and the surface size. And if we look at this object as another example to illustrate, here I'm saying that my target depth is once again 100 centimeters. And the texture, the space it's representing, is also 1 meter. So the height scale is set to 100. If I tile the object twice, well, now the object's representing 2 meters, so the space, the volume is also represented as 2 meters. But we still want the height map to only represent 100 centimeters. So 100 divided by 2 gives us 50 for the height scale. And here's the same for 3 meters. But what I want you to notice here is how the object's maintaining its volume. It's not stretching or distorting in any way. If we were to set the height scale back to 100, you can see how the shape will stretch to fit that 3 meter space. And obviously this is no good, so if you want to be working to real scale, you need to have your metrics defined. So with the math out of the way, for Manhattan, we actually used 16 by 3. And we chose these numbers because that's what the height to normal node actually defaults to, and it just so happens to fit perfectly with the map. And if you think about it, 16 centimeters is a pretty good amount of depth. If you have any more than that, you probably want some geo support. So our height maps look like this. Textures with a lot of depth, like this debris, are using the full range, while textures like this broken concrete, well, its surface is flat and has no displacement, but the missing chunks are then subtracted from that. Mostly flat textures then, well, they have very little displacement at all, so they're only a few values up and down from mid-gray. And with this setup, all the materials will exist in the same scale, and we know that they're going to work well inside a painter. So at this point, we know what we need to build. We've got some metrics to build within. So next we look to establish like a common theme. And what I mean by this is to find something that can be incorporated across many assets with the intent of making everything feel like it belongs in the same world. We already touched on this when we discussed the environment layer during the planning phase, and these are those ash and dust materials. Now these materials, they're there to help unify the scene. They serve to be the underlying theme across the whole map. These materials, they never really got used in their pure forms, as you see them here, but rather they were used to blend into other assets, like this material. And this is what that looks like inside Designer. Like we're simply using the full material itself and then blending the different channels in. We're looking at the height data here, and the diffuse and gloss gets blended somewhere else off screen. But also, I want to point out that sometimes we're even reusing full materials from somewhere else in the map. And in fact, almost every material made for the map incorporated this ash and dust in some way. And this was also true for the props, which had the ash and dust layered in. And much like Designer, it's just using the full materials and have some masks applied to blend them. But I hope you can see how it's a conscious effort to bring the asset into the world. And in some cases, we would adjust the ash and dust to look a little bit different. Like here, we try to make it feel a little bit more like mud, but it still originates from those core 2 materials. And if we look in game, you can see how it all comes together. Almost everything has this layer of ash and dust resting on top. And it doesn't necessarily need to be a material. Like here, we're using some sculpted bricks in a wall texture. And those bricks are also used in this tileable debris material, as well as the actual pile asset itself. And it all originates from these meshes, and they were authored in ZBrush. Now, these assets, they share the bricks to make them feel like they belong in the same environment. And you might notice how the meshes are also arranged in a grid. And that's so that we can bake out an atlas sheet and use the data inside of Designer. Here, for example, we're baking out an ID, height, and alpha channel, but you could bake out any of the texture channels that you need. Now, Designer isn't really great at handling large images, so we actually run those images through another substance graph first and crop out a bunch of smaller ones. And then we use those to turn them into a small reusable node inside of Designer. And using the multi-switch nodes, we can then just cycle between all the images with one slider. So if you expose that slider, you end up with a great little node that makes it easy to incorporate all these assets across many materials. So you can see maybe that the wood splinters are being used in this material. And these asset nodes, they work really well with the tile samplers, for example. Now, some of the materials, they use more than one of these atlas nodes. Like here, we're using the wood splinters again. But we're also using those bricks that you just saw. Some materials would use more than one element. Like here, we've got the ash layered in, alongside those same wood splinters, and of course, the same bricks. But I hope you can see that this is all connected regardless of the material that you make. And that hopefully everything is brought together and feels like it exists in the same world. Now, these little atlas nodes, they're really powerful. I can't stress that enough, especially when you start using them with scanned data. Our main source for atlas textures themselves was Megascans and Textures.com, both of which have really great atlases as well as scanned models. Now, so far, I think this makes intuitive sense to a lot of people. Like, of course, you reuse assets where you can, but I think it's important to conceptualize like exactly what we're doing here. Remember, we need to texture a whole environment, and everything must work together. Like when we're offering this content, there should really be this clear design intent behind it. If you don't design the assets to work together, then things will start feeling out of place. Now, I know that sounds a bit wishy-washy, so hopefully I can illustrate. But this is an example of 3 materials that are intentionally designed to blend together. They can be thought of as a blending set. What makes them work is they're sharing a common color scheme and the same kind of debris. In fact, they're all using the same Megascan Atlas nodes. But the design intent is specifically in how they're authored. We can break it down into stages of transition. On one end, we would have this kind of more wet puddle type of mud. And on the other hand, we have a drier, more solid type of mud. And then a transition material. Now, the transition material is created by simply blending the other 2 graphs together. But it's important to realize that we're not just picking random mud materials because we think they look cool and then combining them together. We're intentionally authoring a transition, with each material being a self-contained graph and designed to blend together. Now, these blending sets, they don't necessarily need to be 3 materials either. In fact, most of our materials are only most of our blending sets are only 2 materials. But they're still sharing a common asset between them. So as we look at these sets, what I want you to notice is that these materials are designed as a transition from one extreme to the other, or from smaller pieces to larger pieces, again with some kind of theme to bridge them. So as I mentioned before, most of our work was done with the substance tools. And as you work, you end up creating these little reusable sets of tools. And if you step back a moment and consider the studio as a whole, with a bit of tidy up, most of these materials, most of these tools would be very useful for other people as well. Now, production can be pretty chaotic at times, so although most of the stuff we'll look at was developed for the map, it wasn't until after production that we actually went back and kind of then, tidied everything up. But one of the first things we did do was create this output controller. Now, it's used at the end of every graph, and it just exposes some common parameters. Like there's an option to change the color for the whole material, or change the overall gloss value, There's some intensity controls for like normal and height depth. And we're also exposing sharpen for all the layers. Sometimes a bit of sharpening is nice, but you don't want it baked into the material because you might be using it in another graph. And then finally, we have this debug mode, which we use to double check all our specular and albedo values. So a typical graph might look something like this. I know it's pretty small, but you don't really need to see everything. Only that we reuse materials that we previously made if we can, and that everything is always going to have this output controller at the end. And then with this, every material is going to have a consistent set of parameters. And this feels really nice, especially when you're inside Painter. Now, you might have a bunch of other settings which are specific to that material, but you're always going to have these common settings. It feels good. When you grab the material, it's immediately understandable and familiar, and it sort of just builds trust amongst everyone. Some of the tools that we built were a little bit more specific. For example, this wallpaper node. As we started to build a bunch of variations, like you realize there's parts of the graph that you would like to reuse. And it's simple things like the number of paper strips or how loose they are. It makes sense that you would want to split this out into its own node and expose some of those settings. In that way, other people can use them too and create all kinds of different variations. And we did this for quite a few things, like this loose debris generator, which we used if we just felt that the texture needed a little bit of debris. It's another nice way of implementing like a common theme across a set of materials like we discussed. But you can see how this sort of thing really helps to bring an asset into its environment. Here's an example of a trim generator, which we use to just create different kinds of wood frames based on the shape that you would input. Now, this actually got converted into a concrete panel tool in the end, but it was originally designed as a quick way to create trims. These basic textures are interior walls that were used in the Vista buildings outside the playable space, and all their trims were created using this tool. Now, sometimes your tool is going to be a little bit more involved, so don't be afraid of splitting that task into a series of smaller ones. For this example, we split that node into one that would handle the surface breakup, which we did by just blending two height maps together in a more kind of concrete type fashion. And then another node to handle the rebar. And because we're exposing these parameters, you can get a variety of different looks. And you can get pretty extreme with it. Now, we could have had this all in one node, but splitting them out means that they become a little bit more versatile. When they're separated like this, you also only need to compute part of the graph that you're currently working with, which helps to keep everything a little bit faster. And we did this a lot. Like, here is just a set of nodes that are related to just concrete. But I hope you can see how each of these nodes, they're designed to solve a single problem, and they're all fairly quick to compute. If this was all in one node, I think you could imagine how slow and sluggish it would be to work with. Now, it's also worth noting, too, that all of these nodes are based on scan data with this kind of procedural layer on top. Now, the specific content of these nodes isn't really what's important here. The point is that each of these nodes they're small and fast, and they're there to solve a specific problem. Like, they have a singular purpose. And this is important. If they're sluggish or overly complicated, people just won't use them. So aside from speed, what else can we do to make these tools appealing to use? I think if there's any programs in here, they'll be happy to see this, and we should totally steal a leaf from their book. But the idea of abstraction is, well, the people using the node, they don't necessarily need to know what's happening inside, only how they should use the inputs and what kind of outputs to expect. And if we put this in terms of designer, it means simple things like using descriptive names. Histogram, scan, position 5 really doesn't say much, while blending contrast does. You want to look to group associated parameters together. Like, everything here is related to rebar, so it goes under the rebar settings. And you want to keep the sliders simple. Like in in this bottom example, all the sliders range between 0 and 1 or -1 and 1. And that makes them feel easy to use and relatable. While on the top is, I mean, what's 43.34 base uniformity mean? You want to maintain a common naming convention wherever possible. You want to use words like intensity or depth consistently throughout a set. And I think the output controller from before is a pretty good example of this. As a result, every material is going to have a consistent naming convention. Now, perhaps a little less known feature of Designer is the visible if condition. And it's really nice. It lets you control what's visible in the UI based on a given state. Now, most of the attributes in Designer have this condition available. So to illustrate, we can take this common problem as an example. Let's say you have an awesome tool and it can be either triplanar or not. So you expose a switch alongside all of the triplanar options. Now, the problem is that none of these settings would actually work if triplanar is off. And these inputs are pointless. They just kind of get in the way and confuse the user. What you really want is that everything is hidden related to triplanar when it's turned off, but visible again when it's on. And that's exactly what the visible if condition does. So here we're saying to only display this parameter if the triplanar Boolean is true. You know, sometimes you just can't help it though, and the stuff you make, it's inherently complicated. You know, and that's okay. But then consider creating like an examples graph. It can act as a sort of README for the file, for the node, sorry. In here, you can show some simple setups on how the node should be used and what kind of results it can produce. You know, that way people can come and reference it if they're unsure on how it should be used. Now, the point in all of this really is that if you just package it up nicely enough, the other artists are going to use them too, and everyone's going to work a little bit faster. So before we end the talk, we'll do a little recap, after which there'll be some time for questions. So we started with looking at some concept art, breaking it down into what we thought were the core materials for the scene. And then we conceptualized this sort of environment layer, which we said can be thought of as the state of the world. And then we moved on to planning, when we wrote down everything that we needed to make, even doing some mock-up textures if we felt that we needed it. What we're really doing is defining how the texel ratio is going to interact with the size of the modules. And then we discussed what that plan looks like in terms of production. Like we set up some metrics for every material so we know that they're going to work together. And then we looked at how you can establish a common theme to tie everything into the same world. And then we tried to define exactly what we were doing when we were authoring all this content. And then lastly, we discussed how the work we produce can then be further developed to generate greater value for the entire studio. And the key takeaway here being that you want to keep things small and purposeful, and that you should really look to abstract the user wherever you can. So that concludes the talk. I hope you enjoyed it, and if you have any questions, then I think there's a mic to go around.
Hello, thank
Hi.
you for you. I have a question about QA. For example, we created a material, but material works very slowly. For example, a rebuild material have 4,000 milliseconds. You have any maximum parameters and maximum millisecond of material?
No, not really. I mean, that's certainly a problem for some materials. Some are way more complicated than others. And honestly, I don't know if there's much you can do about that. As you're working, I think you obviously try to be as efficient as possible. And I think it's good practice to kind of, after you've done a pass, to then go through and try and optimize where you can. For us, though, like we don't use these materials in real time. They all get exported out to textures in the end. So performance or compute time isn't so much of a concern, much less so than the actual result itself. I think it would be very different if we were using them in real time and they need to be quick.
Thank you.
Ben, thank you for your presentation.
Thanks.
Thank you for the Manhattan. Thank you, your colleagues, for the whole game.
Yeah.
Definitely, it's, now I want to load the Manhattan and watch it closer for these details you showed us. The question is, how much time does it take to create the whole location from scratch till the final production quality?
That is a very difficult question to answer because, I mean, although I worked alongside Ivan predominantly on the map, you know, when you're in a studio, you tend to get pulled around quite a bit. You'll spend maybe a few days here and there helping someone else out, or you know, this thing needs to be delivered really quick, so you have to kind of move on to that. It's really difficult actually trying to put a number onto this. I joined the company, two years ago now, and maybe has 9 months of production between a few maps. So a rough estimate, I suppose, could be anywhere between 3 to 4 months. But yeah, we like I said, we came onto this after a blockout was already in place. So there was a whole bunch of work already done.
Thank you.
Hello and thank you.
Thanks.
I would like to ask, how do you approach making textures for lower LODs? Are these assets designed so you can use the same bitmaps, or are you making extra textures for lower stages of assets?
No, not really. Our loading solution was simply gone, which handles an awful lot of the manual work that you would do there. The maps are generally a lot closer proximity, so although there is obviously a lot of loading that goes on, the combat is so frantic and fast, and the spaces are somewhat enclosed anyway, that the main consideration is making sure that LOD 0 works. There were some I guess, specific assets offered to work at a lower MIP, such as those Vista building textures, for example. You know, they're very plain and very simple because you just don't need to put the time into making them look good, and if they have too much detail in them, you're just going to lose all that detail when they MIP anyway. So yeah, most of the consideration was spent on LOD 0.
Okay, thanks.
Anyone else? No? Then let's give Ben a round of applause. Thank you.